Hello friends, welcome to Programming Concepts. My name is Amit, and in this video, we will learn the basics of dependency injection. With the help of same example, we will learn inversion of control, dependency inversion principle, and dependency injection. We will also answer the very basic but most confusing question which developers have, that is, how dependency injection help in unit testing. We will also explore how web.config can be your best example in interview when explaining about inversion of control. And last but not the least, we will also answer why should we use dependency injection when we already have dependency inversion principle. So dependency injection itself is not difficult to understand. You must have heard dependency injected via constructor, method or property, and that's it, you are done. The real problem arises when you start comparing different terms available in the market, in the IT industry, like IoC, inversion of control, dependency inversion principle, DI or IoC container. This is the time when we start doubting ourselves, why should we use dependency injection, how they are different from each other, etc. etc. We will compare and cover every aspect in this video. And by end of this video, you will get all your answers. Alright, so let's begin. Before moving forward, it is really important to understand what dependency and tight coupling is. Let's say, for example, we have a class B, and this class B has some dummy method, and that will do something. That's it. A class B is ready. Then we have a class A, where we declare the variable of class B. And within the constructor of class A, we instantiated the object of class B. So if we created some class that must be responsible for doing something. So for that, let's say class A has to perform some task. Let's name it task 1. And here we do something, and the activity of task 1 is dependent on class B. So we call the method of class B, b.dummy method, and then again we will do something within class A. That's it. Simple, very straightforward example. But if you can see that task 1 is dependent on dummy method of class B. So it has some kind of dependency on class B. And when we initialize the object of class B within constructor, that is tightly coupled with class B. For example, if there is any change in class B, it definitely going to impact class A. So this is what dependency and tight coupling is, in short. So all these concepts, dependency, tight coupling, dependency inversion principle, IoC, dependency injection, these concepts are really simple. But the basic problem with developers to understand these concepts is, when we start our career, we generally have full control over complete application. So we act as a full stack developer, right? Where we own UI, we own services, we own business logic, database and all. Just in case you are also in a similar kind of project, or your team is in a similar kind of project where you own everything. So we just wanted to make an assumption before going forward. So for the rest of this video, I would request you to assume that you don't own even a single other class in your project. Simple. Although this assumption or this statement seems pretty easy, but believe me, for full stack developers or developers like me who started their career with complete ownership of each and every module, even to assume we don't have access to any other class is extremely difficult. So I would request you to make that assumption in your mind for the rest of the video. In that note, let's suppose we have a project requirement with us, and the requirement is like create module to log errors in text file. To achieve this, let's say we will first create class library project, and first class of this project will be log to text, and this will be managed by team A. Second class will be business logic class, and suppose this will be managed by team B. So we will create another project, and that project will be a console application project. And again, this will be a dummy client who will use our project, our organization project or services. So here we are creating a class library project. So this console application project will consume our class library project or DLL. And assume our class library project will be used by similar multiple clients. I already created both the projects in Visual Studio. Let's see, this is our empty class library project. And the next one, this is our console application project. So let's get back to slide and create both the classes. So public class log to text, bracket open, public void log, string message. So console.writeLine message, bracket close, and your class is ready. So here, just assume that instead of console.writeLine in real world, it will log your message into some kind of text file. Let's create another class. So public class business logic, bracket open, log to text, let's name it underscore obj log, public business logic, bracket open, we created a constructor here, and again obj log is equal to new log to text. Public void dummy method string message, and this method will consume log to text method, which is log, bracket close. So if you look at this code, this project is similar to what we had shown you in the slide of dependency and tight coupling. So here you can see business logic is dependent on log to text class. Alright. Also, business logic is tightly coupled with log to text because we created the object within business logic constructor. So the question is there any problem with this implementation? Because we already following such kind of approach since we are doing a development, correct? So in general, not a big problem if you have control over all the classes and your project is small. Let's see the problems one by one. So the first problem is, in case of change in dependent class log to text, we need to make changes in all places where we are referencing this class. Okay, let me just copy and paste the code in Visual Studio. So open a class library project, right click on the project, add a class, and let's name it businesslogic.cs. Click on add. So let's copy and paste our code in this particular file. So this is similar code which we have seen in the slides. We have a business logic class, we have a log to text class. So the problem statement was, if there is any modification in log to text class, then it will impact all the classes which is referencing this class. All right. So for example, this class, as of now, we have a default constructor which is created by .NET itself. Let's create another constructor. Public log to text bool is valid. So what will happen now? It will start impacting business logic class. And in this project, seems really easy that you can modify the business logic class. But in real world, that log to text class might be used by multiple projects where you don't have much control over them. So this is one of the problem, that we need to modify all the dependent classes who are using our class. Let's get back to the slide, and let's say in case of future upgrade, our product starts supporting logging the logs into the database. All right. So again, we need to make modification in all our dependent classes. Let's get back to the code. So here you can see that log to text file is hard coded within business logic class. So again, all the classes who are referencing log to text, we need to change the name to log to SQL database or something. To make it easy, let's create another class. Let's just copy log to text class and let's rename it log to SQL database. So now if business logic class have to consume log to SQL database class, they need to rename log to text class with log to SQL database class. And that log to text class might be used in 1,000 other classes. Alright, so you need to rename them again in all the classes. So if you are from a .NET background or using some powerful IDE like Visual Studio, then you must be wondering what's the problem in renaming log to text class. So if I have to rename log to text to log to SQL database, then what we can do, we can just right click on log to text, click on rename, and rename as per our convenience like log to SQL database. And then what I will do, I will click apply. So that will rename log to text to log to SQL database across application, correct? If you are thinking in that way, then you are still in full stack developer mode. Remember, I asked you to make an assumption that you don't have control over other classes, correct? So you can make modification in business logic class. There might be a possibility that other class which you don't own. Another possibility is that this particular DLL, class library vendor, so this particular DLL might be used by some other project where you don't even have access to their code, correct? So let's see how we can overcome these limitations. For that, first we need to understand what inversion of control is. So let me read out the definition, then we will understand what actually the concept is. So inversion of control is a design principle. Remember, it is a principle, not a pattern. It is a design principle used to invert different kinds of control in object-oriented design to achieve loose coupling. The main objective of inversion of control is to remove dependency between objects of an application, which make the application more decoupled and maintainable. Inversion of control is a principle which means it is a general guidelines and end user can choose the way how they want to implement it. Alright. So let's use this principle to refactor our code. So this is our existing code. So let's create another class, public class factory. And this class have one static method, public static log to text get logger. And it will simply return log to text object. That's it. Our factory class is ready. Now we need to refactor our business logic class. So public class business logic, log to text underscore obj log, public business logic, this is the constructor, bracket open. So now there is a change. Instead of creating new log to text, let's use the factory class to provide us the instance of log to text class. So obj log is equal to factory.getLogger. Other code will remain the same, public void dummy method, string message, bracket open, underscore obj log.log message. That's it. So if you look at the code closely, this will resolve the problem statement 1. In case of change in dependent class, log to text, we need to make changes in all the places where we are referencing this class. Now if multiple classes are using log to text class with a default constructor and there is a change in constructor, then we only need to make modification within our factory class. So that will be our central point. So what we had done here, we just inverted the control. Previously, business logic class has control to create the object of log to text class. Now we just give this responsibility to another class. I know this is a very basic example of IoC, inversion of control, and that too is not implemented properly. But that's what inversion of control is all about. We are just inverting the control. Just in case if you have any confusion, let's cover another example of IoC. Another very good example I can think of IoC is connection string in web.config. What? Connection string in web.config? But how? Let's see a practical example of it. Let's get back to our code. Let's create this method within business logic class. So public string get connection string, and that will return configuration manager. Press Ctrl dot to add the reference dot connection strings, and let's name it my con string dot to string. That's it. So this connection string my con string is not present within my DLL. I haven't specified it anywhere, correct? So let's rebuild our class library project. And let's get back to our console application. I already added the reference of that class library project. And if you can see in the app.config, I already specify one connection string with the name my con string, which is there in my class library project. And here it is. All right. Well, let's go to program.cs file, and within static void main method, let's write new business logic, control dot to add the reference, dot get connection string. That's it. Our code is ready. Now if I run this program, what do you think what would be the output? So if you have guessed that it will return the connection string which is present in the console application, our client application, then you are correct. All right. But how it is possible? So that's what internally inversion of control is all about. So ideally we should define the connection string and everything within our class library project. But what we want that it should be provided by our client. So my business logic class is not own the responsibility to have the connection string, right? So that responsibility has been provided to the clients. Now I hope you understand the concept of IoC slightly better. Just give the responsibility to someone else who can manage it better than you. All right. Let's get back to the slide. So with the current implementation, we are able to get rid of problem 1, but the problem statement 2 still persists. Let's learn another concept before getting rid of this problem statement. And the new principle is Dependency Inversion Principle. So let me read out the definition. I already covered Dependency Inversion Principle in a great detail. So you can watch that if you are not much aware of Dependency Inversion Principle. I will share the link in the description. So the Dependency Inversion Principle states that high-level modular classes, high-level, should not be dependent on low-level modules or classes. Both should depend upon abstraction. Also, abstractions should not depend upon details, but details should depend upon abstractions. Again, I am assuming you have basic idea of what DIP is. Just in case you are completely unaware of what DIP is, I would strongly recommend to watch that video and then get back to this video. All right. So let's refactor our code according to DIP. So first create an interface, public interface ilogger, void log string message. Then create our log2text class, public class log2text, and that class will be inherited from ilogger class. Next is method public void log string message, console.writeLine message, and that's it. Our log2text class is also ready. Next is factory class. So public class factory, public static ilogger getlogger. So instead of returning the exact class name, we are returning the interface. Return new log2text class. And that's it. Our factory class is also ready. Our final class is business logic class. So public class business logic. Now again, instead of log2text class, we are using ilogger interface. So ilogger underscore obj log, public business logic, and again underscore obj log is equal to factory.getlogger. So the responsibility is still with factory class. And rest of the code is same, public void dummy method, string message, underscore obj log.log message, and that's it. Our business logic class is also ready. So this code will solve our problem statement 2 as well. For example, in future, if we need to save these logs into a database, so when the new class will be created, so that will also inherit it from ilogger interface. So in future, if business logic or similar other class wants to use log to SQL database instead of log2text, we only need to make modification within our factory class like this. And that's it. Everything is perfect, right? So all the scenarios and all the problems has been covered. But there is still one problem. Like the control to select logger class is still within our business logic DLL, right? And that DLL will be consumed by our clients. And our client project, console application project, is still not in control to select which logger class they wanted to use. So here is the expectation. Just like we had specified connection string in our main project, console application project, and our DLL picked it dynamically. Can't we create such mechanism with our code as well, so that our end user is in control to select which logger they want to use? Obviously, depending on the scenario, you can use if and else statement to achieve this, but let's see how to do it in an efficient way. Let's learn dependency injection. So dependency injection is a design pattern that used to implement IoC. So IoC was a principle, DI is in pattern. It allows the creation of dependent objects outside of class and provide those objects to a class through different ways. Using DI, we move the creation and binding of dependent objects outside of the class that depends on them. So there are different types of dependency injection available, like you can inject it via constructor, you can inject it via property, and you can inject it via methods. So let's refactor our class. So our interface will remain the same. Log2Text class will remain the same. There is no need of factory class. Let's refactor our business logic class. So public class business logic. Let's create an object of ilogger underscore obj. And within the constructor, specify the parameter as ilogger. Let's name it underscore logger and assign this injected ilogger object to our local variable. Next is public void dummy method string message objlog.log message, etc., etc. So this is what we call dependency injection via constructor. So because we injected dependency of log2text file via our constructor. Now if end user or the client can use it like new business logic, new log2text, bracket close dot dummy method my log message. So that will work the same way it was working previously. Let's see how it will work in our code. So let's copy and paste the code of our DLL class, rebuild that DLL, and within our console application just write new business logic, bracket open, new log2text, bracket close, again close dot dummy method my log message, and that's it. Just run the application and eventually it will print my log message. So we successfully injected the dependency of log2text class. In future, if client want to use log2SQL, then instead of using log2text class, they can use log2SQL database class. So the control is with the client, not within our DLL or the jar file. Let's get back to the slides and see the benefits and drawbacks of this approach. So the benefits is it provides loose coupling. It will help in unit testing. Drawbacks are no compilation time intelligence and chances of runtime error. But wait, help in unit testing? But how? Let's see how this approach will help us in unit testing. So let's see the code without dependency injection. And here it is. And let's assume that we need to add few more parameters to log2text file. So let's assume this log2text file has a couple of parameters like ID and name. The only problem is that ID we need to fetch it from database and that name we need to fetch it from client API. Now, because the responsibility is with class itself, you cannot provide dummy data to this class, right? So let's say your manager say, provide me the unit test report with logger with ID 1 and logger name is pro. Developer, but client database and its API is not available for any reason. How does it matter? I only want unit test report and boom, you're stuck. But if we had used the dependency injection approach, then unit testing will be quite easy because the responsibility is someone else, to the client. So we can simply test it with obj ID is equal to 1, obj name is equal to pro, and then business logic obj BL is equal to new business logic, and done. That's it. A unit testing is completed and independent of database, independent of any API. I hope these simple examples will help you to understand what DI is, their significance, and how it is different from IoC and DIP. So that's it from this video. If you have any query, do ask me in comments. Thanks for watching.